All right, guys, here is your two favorite mechanics are back at it. The world champion garage,
That's
right?
it. We are. We're here.
We're here. We have been, they said it's going to be lovely 72 degrees with an overcast, and as you can see, we're sweating. They lied to us, right?
They lie. They always do.
All righty. We're going to show you today what we did here. And as you can see it, we got a setup here. I'm going to turn the camera over to our NBA world champion, and he's going to video this, and then we're going to show this with that test. And that was not easy, but we will explain this here in a second.
Rolling.
Rolling. I'm waiting for you to say rolling. Remember, rolling. All right, so we took out, the first thing is we took out the hydraulic lifter element, and they were stuck again, right?
They're stuck.
Yeah, they're stuck, and Clay cleaned it out, so I need 16 new hydraulic compensating elements, that's what they call them. Let me see, where did we put our little feeler gauge? Here. We have this thing now set up here, and we put in the fixed set screw of what they call this, and just to show you, this here will fit through, and we'll basically have a bare clearance on this. If we wiggle a little bit with the 14 millimeter core foot, it will immediately look up, but we're basically clearing this with the what is this here, 0.04 millimeter. And you can see this is, we're now at top dead center for cylinder number 1. And you can see that this valve has just closed. Our intake valve and the exhaust valve is already closed. Our distributor is at the mark for cylinder number 1 to fire, and we're right at the 0 mark down here. I don't think you can see the 0 too well. Now what's going to happen is when we start rotating, take a real good look at the cam lobe. The cam lobe is for the intake valve is on the other side. So as soon as I start to rotate, we're going to be basically on top of it. When we reach the 27 degree mark where we need to be for the 2 millimeter displacement. Right now I have a preload of about 5.5 millimeters. And we're going to try to go down, but we have to rotate all the way through. So I'm now coming up, I'm actually over 30 already, I'm now at 35. So you can see that this is not going to work, so we have to rotate this over until we get to the bottom top dead center of the piston number 1. And it is at that point that the valve is going to start open. The bottom top or bottom dead center is indicated when we go through the 0 mark on our flywheel again. We're coming up now, if you can show this here. And I believe this is on firing. This is going to start fire on cylinder number 6. So when 6 is actually ready on top dead center, number 1 is on the bottom dead center. And I'm coming up here now slowly on the 0 mark, which is 10, 0. And now we can see this where our lobe is here. And we have maintained our, now we need to show the dial. So now we're gonna go from 5.5 millimeter to 3.5 millimeters. And this will start now. And I'm over here, this is the first millimeter, we're going into the second millimeter, and here comes the second one, right here. And now we are at 36. We have to redo this. This thing moved in us, and this is the problem here, is the dial here moves. And it basically gets itself out of alignment every time you rotate this through. So let me rotate this one more time. I don't think we will be able to really video this. See this? Now we're coming up again under 0. And then we have to double check that we are exactly at our preload, that the thing is set correctly. We can go here, I think. See, once it goes too far in this curve here, we're going to be on the edge, I think. Let's set this to 7. This is a very, very bad setup here we have, and it is very inaccurate if you're not. I don't think we can show this. Let me do a 2 millimeter. Where am I at? 7. 1 millimeter, 1.5, 2. Yeah, now I'm at 30. You see, this varies with every time we do this. Cut the video. Rolling. Okay, so we're picking up here. We cut the video. You could hear me say yesterday, cut, when we were doing the setup of our dial gauge. And what we found out, this is where we start to finish the video, the previous segment, is that we cannot adjust or hold the dial gauge in a proper place so it won't move on us. These dial gauges have these extenders here I got, and the extender has a screwable, can you see that, ball on here, which is spring loaded, and it just moves like this. Can we show that?
Yeah, we're getting a good picture.
All right. And this thing is supposed to be holding that straight down on the valve, so we can actually measure this. And what happens now is, since that is not 100%, it's starting to move it as this whole thing moves like in this direction, even though it has a ball, and that changes the readings we get with every time we rotate the engine through. So if one of you experts out there who has more experience with this kind of high precision machinist background, which neither one of us have, you can leave a comment, and maybe we gotta be able one day to properly show this on how this is done. This is the setup we were trying to get to, which I had showed in my other video, with the pin basically going in this way. And we cannot get this, not with this here. Like I said, it's the original version Mercedes-Benz has is this magnet holder here, this one here. And you can basically use this, but this is the one they have in this picture on the bottom here, on the rod going straight up. And this seemed to have placed this in the correct position and holding this. And this is only on the engines until 1976, when they were cast iron rather than cast aluminum, since this thing is basically completely useless. And this is the one we tried, which you saw in the video, and we couldn't find a good location to actually clamp this to. And you cannot put this on the camshaft bearing holder bracket thing there, because the lobes will run into either one of these two sides, and then it's gonna knock you out, and you may damage the lobe of the camshaft itself. That was basically it. So on one try we came to 28 degrees, and we should be at 27 degrees on the side. We came to 27. We should be at 27, and we came to 28. And then on one try we came out to 36, and then even to 40. And this was because the tool was moving on us, and it would delay the release of the 2 millimeters. So it kept on traveling with the valve rather than showing us the displacement of the valve by 2 millimeters. So that's why we kind of had to abandon this. So we're going to be probably realistically anywhere around 28 to 30 instead of 27, in that range, with this chain now, which has 10,000 miles basically on it, 20,000 or 12,000 miles, 20,000 kilometers. Now the other thing is, let me show you. So this was, unfortunately, we had to abandon this test. But before we actually did this, we got a new, what do you call it, the Borescope. I went out and I got a Borescope on Amazon, which has a higher resolution. It has 1080 for picture and 720 for video. And I guess you can see this nicely now. You can see you can rotate this in this direction and in this direction. This will go only 2 ways instead of 4 ways or 360, which means if you want to do, say, like the side walls, you have to go this, and then you have to, this is tricky, you would have to go this way around it and rotate the camera while you're holding this here in a 90-degree angle rather than 180. And that was a challenge yesterday, as Clay can attest to, right? To get to this. But we were able to take video and pictures, and I will add some of the video we took on this camera here. But this is basically one piston. You can see what we got here. We got the carbon buildup. I'm going to hold this here, then I can hold it more steady. And the first thing is what we verified was the 27, F27. So now we can nicely see the 7, and the 2. Let me turn it around. So we have the F here, the 27, 7 here, 2 here. This was the one we couldn't see, and you can see me right here holding the camera, rotating it right here. This is the camera when I was looking at it. And Clay rotated the engine through until we had the F number coming in on the passenger side. So we have F26 on the left side and F27 on the right side, and those are the magnesia phosphate coated camshafts. These are not the original camshafts because they came out after the manufacturing date of this car, which was, my car was March 89, and they weren't introduced until October of 89. So we know that the camshafts have been replaced. These are not the original camshafts on here. And then we went back in and we did some more testing. So this is now another cylinder on the right hand side, and you can see that the walls have no scorings whatsoever. There are these liners or sleeves, pistons. These are the piston sleeves, right? Yeah. Mm-hmm. Yeah. They're fairly new, but you can also see this is now the passenger side, our passenger side. So the right side is the exhaust valves have more carbon burn up on it naturally, and the intake valves are almost virtually clear on this. You can see this here too. That is the top of one of these pistons. Now on the other side, we have oil leaking through on the left side. And you can see the oil stain here, and this is the open exhaust valve. And I think this must have been cylinder 5, right? Mm-hmm. Yeah. So here you can see it a little bit better. The valve is basically open. You can see on how much carbon deposits we have on there. We took quite a few pictures, and I will show you this in the video. This is the videos we took. I will edit those. And what we found on cylinder 5 was already the last time when we put the seals on it. We're good here. Let me just make sure it's not going to fall down. Is that on cylinder number 5, that was actually the intake valve. It was the second valve, right? The second valve, 5 intake valve. The guide, the valve guide itself, which is this little part here, which extends into the head or below the head, into the intake opening, and then has the seat, the lower spring seat holder retainer thing there clipped on it. And then on top of this, that's actually where your valve seal goes on. The valve shaft seal, basically. This whole thing, when I pulled that seal off, this whole shaft piece here, guide piece, moved up by about a half an inch, I would say. Yeah. And it almost looked like it that our valve was going to drop in. And this is where these oil leaks are coming from. That means that valve guide here was pressed out at one point, and then a new one was pressed in. And they either reused the original guide, and that hole is now too big in the aluminum head, or they used the next size, the oversized version they have, and the machinist honed it too much. And then it basically started to now just move up and down. And this is the 3 cylinders all on this side, on the left side where we have this, either on the intake or on the exhaust. And what happens then is when you turn the engine off and the valve is kind of in the closed or semi-closed position, is that the oil will travel underneath that normally sealing lower ring, and it will then seep through the engine head and that space you got here, and that's when it's starting to drip in onto the head, and then it starts to run out on the head into the cylinder wall, as you saw it in this picture. And this is now even with new seals on there. This is this here, so you can see it runs off on the down from the opening from this valve seal, seat, the valve seat. It seeps through there from that upper stem, and then it goes down, and then it runs off very thinly, and then it stops whenever the engine cools down. And this happens only when the engine is at operating temperature or higher. And the only way we can fix this is basically by pulling off the left cylinder head and then pushing out the guide seal, the valve guides, and then checking the diameter to see on how big the hole actually is. The diameter is in the engine, in the head itself, and then see if we can even use a oversized guide, and then find a machinist who knows what he's doing to properly put that in, hone it out, or fix it. And if not, then I have to get a complete new head, which still has the reduced diameter on there, so we can actually press fit the correct valve guides in there. And that is basically what we got here. But like I said, is this issue with the oil leaking through is only at the time after you have driven the vehicle, usually on a highway at higher speeds, and you turn the engine off, so the engine is fully expended. This is going to be even a bigger problem during the summer months, where we had now 105-degree temperature, ambient temperature, and you got the air conditioner running, where the maximum heat build up now happens in the engine compartment. And when it cools down, the metal, especially the aluminum, is going to start shrinking again, and it will basically seal itself off. But the engine had set for I would say 14 hours at least. The car, Friday, I came over to Clay's house on Friday afternoon, and we parked it, and we didn't turn it on at all. So all that oil you see in this video is from Friday, from me driving 20 miles from my house over here to Clay's house over the highway, and then about a quarter mile or so to his house. You've seen that in the other video. And then it basically stops. There's no more leakage when it gets cold enough, but we were able to move the whole thing with my pliers. Now I don't know where I put the other pliers, but basically these type of pliers where you can pull off the valve seals, and when I usually go left, right, and then I pull them up, and in this case the valve seal attached to the valve guide with the lower retainer for the springs, all of it came up by 1/2 inch. And then it broke free, and we had the valve seal separated from the valve guide where they stick on. And this was with the engine cold, sitting for 14 hours. So this has no more holding force itself. The guide has no more holding force. It's basically worn out, or the hole is oversized for that valve guide in the head. In the head itself, in the aluminum. And it could be shitty workmanship. It could be a mistake that they used the standard valve guide in a honed out head, opening, instead of putting in the oversized one. I mean, you name it, we won't know this really until we take it apart. But for the moment, I'm not going to do anything with it. We leave it like this until it further deteriorates. And because the engine, even though this is the most amazing thing, and I think that amazed Clay too, is on how smooth the engine actually idles and runs. But if you have a California car and you have to go to the smoke test for the emissions test every year or every 2 years, and you have that type of an oil leak in there, the way it shows up on these piston sleeves, this will throw off your emissions test, because that oil is going to burn off even in minute quantities while it is running. My oil consumption right now is about, 1 quart per 1,000 miles. 1.6 quart is permissible. So I'm like in the middle of what is permissible, but it will have an impact on the readings on your emissions tests if you have to pass the emissions test in California or in other states which have emissions tests, because that will alter the readings significantly. So you could have a fully working fuel injection system with the catalytic converter and the oxygen sensor and the EHA valve or the frequency valve, and that is all working perfectly and gets your car to the emissions you need. But if you got this kind of an oil leak in there, which is not related to the actual seals but to the valve guide, then you're gonna have then this thing is gonna throw your whole readings off basically, and you won't pass the emissions test. And that basically, now we have shown you everything here, what we wanted to show you. Oh yeah, the other thing is what I wanted to mention is the easiest way to press the Mercedes-Benz on these ones here, the valve seals on, is with a 1/2 inch Culprit. Let me just show you this here. I had a 1/2 inch Culprit yesterday somewhere on this table. Even though we have a table, it looks like it at times we can't find anything.
I'll put it up. It's in the...
Oh, it's in your box already?
Mm-hmm.
Can you grab it? Then I can show it with this here. Basically, this is just a thing, a 1/2 inch. The 1/2 inch will kind of squeeze it a little bit into place. You don't put this on until you have actually manually lifted this over or put it on the valve shaft, and you slide it down on that little rubber condom here, what they give you. You put this on, you lubricate it, and you put it through. And then you just use this thing here, 1/2 inch will work. And you just give it a push down, And we did this with a Culprit and an extension. And this way you can absolutely straight you can see this, our videos are not rehearsed. This is the 1/2-inch Culprit, yeah. On an extension, so this goes on here. And you can see there's a kind of squeeze it a little bit, but you have to press this only minimal. And then you, there's my, this was the ratchet, but there should be a extension for this. This here she is. This is basically what this looks like. And this is similar to the original tool Mercedes-Benz had for those. So you can go around it and you basically put this on, then you come around it, you just place this on there, you give it a final straight push down and you can hear it snap in on the valve guide. This sits on the top of the valve guide. That's where this thing snaps in. And normally when the valve guide is in proper place, when you take these type of pliers here to pull them off, basically you rotate them and you pull them straight off and they snap right out. And like I said, as in our case, this entire valve guide with this lower piece here, springs removed, came up by, I would say, a 1/2 inch. Right?
Mm-hmm.
Yeah. So, and that basically is all there is to this stuff here. You can fix those, but if, like in our case here, the valve guides are loose in the engine head, in the aluminum itself, then you still will get an oil leakage. And now we're gonna go on to Clay's car. You ready, buddy?
Did we stop?
No, we keep going. On Clay's car, we started, I think we showed that in the last video. We started with the climate control unit here. And we got this worked out where we applied a vacuum from the handheld pump to overcome the internal temperature switch, which then allowed the blower to come on in the bi-level or in the other two settings. And then we were able to bleed out the air in the heater core. And then Clay finally got heat. And then we did some checking, and if you have watched Ken Bergsma's videos of Mercedes source, then you know that he made a video. And this is the inside temperature sensor, which sits here in the dashboard on those W116s. I think they put them on the W123s in there too. And it basically sits in here like this, and it connects with a foam tube to a other piece of hose, regular rubber hose, which is then connected to the air blower, and that sucks the air through this. And they did this so they have some they can basically control the amount of air going over the sensor itself. We tested the sensors. We first thought they were not that accurate, but then I took them home. Let me just get the clipboard. And in this test setup here, where we calibrate the potentiometer here, which is the one in the that's basically the position sensor in the climate control unit, they gave me a much better range of what these temperature sensors for the inside and for the outside should be at various different degrees of Fahrenheit. And they came then back that they checked out correct for the temperature when I verified the actual sensor temperature with the temperature they had with the heat gun, basically, not the heat temperature gun. And so they're okay, so we can put this in. And what we're going to do now is to get the indoor or inside temperature sensor to work, is we got us a 6-foot piece of foam that is regular pipe foam, and this is the original coupler they had on this piece of foam here, which connects to the rubber hose which goes to the blower unit. And we're going to use Elmer's glue, and we're going to glue this end in here. And since this is 1/2 inch, this is a little bit big for the hose here. So what we did is we got a 1/2 inch OD rubber hose at O'Reilly's, which is this piece. They cut that down for us, what is about 1.5 inches, 2 inches long, free of charge. And we're going to glue this side in, and then it's going to go on here, and then we're back in business. And then his whole air conditioning system should work fine for this summer. We're just going to measure this out now, and it's probably going to be about that long. And if you want to buy one of those pre-made, Clay said he would make them for $50 with free shipping. Since we got now 7 feet left, this way you don't have to do anything. So we kind of cut this here. I was hoping, yeah, we're having some cutting action. All right, this is about the length what we need here of what that was before. Now we're going to use the Elmer's wood glue. You don't want to use any other glue like Gorilla Glue, because of the solvents in it. It probably will dissolve the foam, and this stuff here should have enough adhesion to stick to the foam. Oops. Yeah. Now we're gonna do the other side. I'm gonna get this in here, and that won't dissolve our foam piece here from the solvents and other, you know, glues, whatever they have, and that will do it. Yeah. So now we have to wait a couple minutes to let it dry, and then we can put this whole thing in there. And the way this thing adjusts or mounts is basically you have to pull these little tabs out here on the side, and then it slides down. Actually it goes like this. So you come through the dash first like this, and this is kind of a fumble job. Then you have to get this over and then push the tube on it when this is in place. That's basically there is to it. We can put that actually in now. And the only thing you have to remove for this is the glove box. So I have to go in. You come in, you got it. Yeah, you go in with your hand. You can feel the hole up here. And we go in this way, and it sits in like this. And then we have to go in with this thing up, and this the lip up. You go through with the cable, and then you just carefully feel this on there. It goes above it. So the theory, yeah. Ah, come on. Did I put it on the right way, or did I put it on the wrong way? Ah, I put it on the wrong way. The lip goes on the bottom side, so the top side goes through this way. Lip, I had it backwards. There it goes. All right, and now the tube is, this is in place, this is snapped in, and then it just connects to this connector here. We'll make sure that this is all kosher here. What we got looks like it. And then we can put this on here. And that's the end of the sensor story. And we just have to put the outside sensor in, and this is the other side of the tube where we're going to hook up to. Let me see if that glue is dry. Yep, that's good. See how fast it settled?
Mhm.
And it didn't dissolve anything. This is still a little bit loose here. This glued better here. That is the trickiest part of the thing. To get the tube on. You can actually, Mercedes-Benz says to take this thing out. The whole thing to get there. So I'm here. We can do this a lot easier, you know. We have a articulating. We'll take the guesswork out of it. So now we can see this here actually where we are. This is my tube. And here you can see the sensors back here. See this? Here's our sensor. So we have to get onto this here with the tube. I wonder if this would be easier to put the tube on first and then slide that over. See?
I think so, maybe.
Yeah. All right, let's try this.
Yeah, it'll be easier that way.
Yeah. So we're gonna just do this way. See this how nicely this fits here? We can pull this out. And now we should be able to get this up. And get this into position. Yeah. I think we may have to take the blower unit out of this. Yeah, this came out already. We have to take the, there's no way around this. The glue is not dry and we have to take this unit out here. Let me see, we need a small screwdriver for that. Yeah. Do we have a small screwdriver, flathead?
Flathead.
Yeah, just a tiny one. This actually goes directly into the tube here on this end. This one actually is the one from the other side, yeah. Unrehearsed. Do we know what we're doing? No. I can't see anything yet. Let me get in here with the camera. Yeah. This here. And then here. They should come out, but they don't. I cannot take this out here. We may want to stop recording here until we got
Okay, so this is now how we put this together. We put that together with a piece of Gorilla Tape. And then you can see it, this thing, if I can guide the camera through. We should wind up somewhere at the sensor. The sensor is right here on the right hand side. You can see it now. Here's the sensor. And you can see it how it is snapped in. And then our hose is attached to it. This is what that looks like. What is this down here? Oh, there's a business card underneath there. See this? Outside the systems. It is laying behind the ashtray. Yep. So here we're going to do the toilet. Oh yeah, you can feel the suction going. Yeah. Let's do the. We're going to switch now back to the normal video.
rolling.
We're rolling.
We're rolling. All right. We made a video which you just saw, and now we got this hooked up here, and you can see it. The thing is pulling the toilet paper basically in there. And when you go to bi-level, auto high or auto low with the AC off, it is not coming on because there is no hot water in the system yet since it is turned off. So with this basically we have that hose section here repaired. We hope we were able to show this. This sits securely in here and the air is flowing through once again. You will have to work with these little adapter reducer hoses basically to go from that 1/2 inch diameter to whatever fits this metric stuff here on both ends. This is the easiest. And this is the, let me see this if I can show this here. This is basically on how we got this into the tube here, and you can see the tube going back there. It is firmly in place. And that was the length now what we had, and we put the Gorilla Glue in there, and we used Elmer's glue, and we used Gorilla Glue on it. And that is basically all it takes to get the AC fixed. And now we can pull this here off and then check the resistances and do the final adjustment on the motor unit to open and close the water, which has 5 positions. We're not going to show that, but this will give you the idea for this on how to fix these AC systems. And to bleed this, Clay said to me he had never seen anything like this before in his life, right?
Never, ever,
Never.
ever.
10 minutes at
It was 10 minutes.
2500 RPM.
10 minutes.
10 minutes with the temperature setting at high and at bi-level, AC off, with the vacuum switch bridged. So the system actually comes on and it opens up the motor unit so the empty air can be drained out. And the only way you're going to have enough push in this is at 25 RPM, 2500 RPM, which sounds high. So you sit there and you have someone else doing the vacuum on the lower side of the unit for the switches in here. So the fan comes on. Once your fan comes on, when you have basically overridden this, then the motor unit will come into force and will go to 5, which is the highest setting. That will allow the full coolant cycle to open up and squeeze out all the air in your heater core basically, and then you have hot air.
Real hot air.
real hot air. And then it will work defrost any of the auto high, auto low, any setting. You can then just readjust this as long as your little vacuum elements are working these flaps to redirect the airflow in it. And use Elmer's wood glue on those hoses, on those, what is it, pipe wrap, right? Pipe insulation, 1/2-inch pipe insulation. This will not dissolve it. And with that, you have a great day. And Clay and I were almost ready to say we go eat. We will do it a
Peace
little.
out. Peace out.
Peace out. All righty.